Thank you for watching my fourth inquiry for Fall 2015 Chemistry 4340. Just some background on this item that we use every day. By 1840, there were many developments of the light bulb. However, the first prototype was built in the early 1840s using platinum. However, because platinum was very expensive, there was no mass production of this early light bulb. We all know Thomas Edison to be an inventor of the light bulb. However, Joseph Swan built a working light bulb as early as 1879. Swan used carbon as a filament inside the light bulb, but by using carbon it caused the surrounding glass to turn black. Thomas Edison did make the first long-lasting light bulb, which he used a cotton thread as the filament. He tested other materials that were to be used as filaments, such as bamboo. By 1910, William Coolidge invented tungsten to use as a filament. Tungsten is a metal that is easier to make and it burns lighter and brighter than the previous filaments being used. In today's light bulbs, we can see that the actual light bulb consists of the glass bulb, the tungsten filament inside the light bulb connected by two wires, and it has an insulated bottom where the electrical current would come through. The insulated bottom would ensure the wires did not touch, would then not cause a fire or any hazardous materials to fall out of the light bulb. Some safety, I had to ensure that I wore goggles because of the filaments being burned inside the glass bulb. I needed to make sure that the filaments would not pop so hard to break the glass jar, which would cause shattering. I used a lab coat in order to ensure that materials would not fall on my clothes and be ruined. Disconnecting the circuit was critical because I was not going to be touching live wires while it was connected. Also, when connecting and disconnecting the filaments, I needed to handle it with care because the alligator clips would get hot after having an electrical current flowing through it. The materials I used were 2 sets of alligator clips, 9 pieces of 0.5mm lead at 2, 3, and 4 centimeters, as well as 9 pieces of 0.7mm lead at 2, 3, and 4 centimeters. I did a 0.9mm lead at 3 centimeters just for fun to see what kind of result I would get. I also used a paper cup, which was actually a coffee cup. I punched 2 holes in the top and in the side to connect my wires into, and I used a glass jar to go on top, which fit perfectly on the cup. I also had batteries 6 volts, 7.5, and 9 volts in a series connected with electrical tape, as well as using an NXT brick and a light sensor. So my light sensor, which is the NXT connected to the NXT brick, was 12 inches away from the light bulb, as you can see in the picture. The power source is the alignment in the series of batteries with the electrical tape, and the light bulb is the actual alligator clips with the filament between the clips inside the glass jar, with the other 2 ends connecting to the batteries. Although I controlled the length of the filament and the voltage, these were also factors that were being manipulated. So a quick mention of error, there was error because in light bulbs nowadays, there is no oxygen in the glass container. And in my trials, I was constantly lifting the jar to remove and place new filament, so that would cause error. And also an error would be how much pressure I had to use to ensure a secure connection with the batteries. I also had to test each battery individually before each new day to ensure I used the strongest batteries to have the most consistent results. I have a sample of my data from 0.5mm lead at 4 centimeters length. As you can see, the average resistance steadily increased as the voltage increased. Now from this, we can see the amount of ambient light being emitted also steadily increased. On average, the data reflects that the higher voltage, the higher the resistance, the more light was being emitted. Now, from my first set of error bars, it looks really big. However, because of the different trials, there was some error in there which would either be from the batteries or from the pressure or from how much oxygen would be inside the bulb itself. My t-test also showed there was no big significant difference between the amount of resistance. However, there was a big increase and a larger significance in the amount of light that was being emitted. So going from 9 volts to 6 volts, you would assume that at 9 volts there was more light being emitted than at 6 volts just because of the amount of power that was going through the circuit itself. And for the most, on average, all of my data did reflect this kind of trend. I also have a short clip to show you of how the actual light bulb looked when being tested. This was an early trial just to ensure that the light bulb actually worked. And an observation that I made during my trials was the longer the length of the filament, the longer it took to burn, but the more smoke it emitted. So it would light the entire length of the filament, but then as the longer time went on, it would slowly get smaller. So where it was being bright, it slowly moved towards the center, which would cause the big light, the lightest part of the light bulb, and then it would pop. So in conclusion, variations of voltage in the light bulb were tested in order to determine which thickness and the length of lead would produce the most light, and I found that at 2 centimeters, 0.5 millimeters, at 9 volts, that had the greatest amount of light being emitted. And if I were to continue this experiment again, not only would I test different filaments such as iron and aluminum, I would also try to have a steadier source of current voltage running through this circuit, because that was also a contributing factor to how bright the light bulb was actually being emitted. Here are my references. Also, a special thank you to Tim Franciscovich and Sam Morales for helping me come up with the idea and the materials to be tested. Also, a special thanks to my father, who helped me work in his garage, as well as helping me record the amount of ambient light being emitted. By the way, here is my battery graveyard. So I used about $50 worth of batteries in order to conduct my tests. Thank you for watching. This now concludes my inquiry for the light bulb.